Hey guys, welcome back. So in today's video, we're going to start working with another type of data structure called binary trees. And so binary trees are exactly what they sound like. They're trees with two basically branches coming off of each node. And so I just wanted to pull up some pictures on Google Images and kind of talk about what they are. This is an example of a full binary tree. And so what that means is that every single node, except the very bottom nodes, have children to them. And so what that means is we have a node over here, that's the one, right? We call this the root node. And this node has a left and right node. And so we call it the left child and the right child. And so if we move over to this node that holds the two, this node has a left child and a right child. And so speaking in terms, the one node would be technically the grandparent to the 4 and 5 nodes or the 6 and 7 nodes. And so this goes on and on until we get to the very bottom of the binary tree. And the very bottom nodes over here are called leaves, and these don't really point to anything because they're at the very bottom of at the very bottom of the tree. And if we have a whole tree like this where all these nodes have left and right children except the very bottom leaves, that is considered a full tree. And then a complete tree is where all the levels are filled out except maybe not all the leaves are there. And so I think it'll be better if I show an example. Oh, wrong one. If we look at this over here, we see that there's each of these levels have are filled out completely, but not all of these have left and right children. The one important thing to note is that all these leaves are to the leftmost as possible, or to left as left as possible. And so this is what we call a complete tree. And so yeah, it just consists of nodes, and they have left and right children, and we go down the binary tree as needed. And so that is just a quick introduction to what binary trees are. We're not really going to be doing too much in this video. One thing I want to do is just quickly make what a node would be for a binary tree. And so if we make the node, it would initialize it with self and data. And so we can say our self.data is equal to the data, our self.left is equal to none, and our self.right is equal to none. And so what we're doing here is that, say we start off on this node, right? We're initializing this node just like with the other linked list. We're initializing this node with a data element. And so we're saying self.data is equal to data. So the data element for this node is the 1. And then we're also, to begin with, we're initializing the left node, or the left child, and the right node / right child for this parent node. We're initializing them to none. And so obviously we can tamper with them later on, but that's just what we're initializing with. And in terms of the binary tree itself, if we say, if we write the init function, what we want to do is when we create a binary tree, we want to create our root node, because like I said earlier, the very first, or the very top node over here is called the root node. And so what we want to say is our self.root will be equal to the node of the data element that we pass in. So if we make a class called bt, an instance of the binary tree class called bt, we'd have to pass in a parameter. And so that parameter would be the data element. And so if we print out bt.root.data, we get 1. And so that is the root node of our binary tree, and we're printing out the data element of that root node. And so, of course, what we can do, we can initialize the left and right elements of these of the root node. And so we can say bt.root.left is equal to, say, node, we'll say 2. And then we'll say bt.root.right is equal to node 3. And so what we're initializing it with here, or what we're initializing here, is we have our root node that holds the data element of 1. We're saying the left node is going to be a node that holds the data element of 2, and our right node will be a data element that holds a node that holds a data element of 3. And so if we print them out, dot left and dot right, if we print them out, we should get 1, 2, 3, because this is the data element of our root node, this is the data element of the left node for our root, and this is the data element of our right child for our root node. And so that's just a basic introduction to what binary trees are. In the future videos, we'll go over some ways on how we can print out all the data elements and print out all the nodes within our binary trees, because there's different ways you can do it. But that's going to be it for this video. Hopefully that's helped you guys, and see you guys in the next one. All right, later.